problem, we said you want to choose a point and plug it in and see what you get. So looking at slopes of 0 can be useful. I probably don't want to choose something like 0, 0 because it might make it difficult to see the effects of x and y. So let's choose this point here, -1, 1, because our x value isn't 0, our y value isn't 0, but we're still getting a slope of 0. So I'm going to plug in -1, 1 and see what I get. So if I plug in -1 for x and 1 for y, so give me -1 times 1, which is -1. Does that match our slope of 0? No. So we can cross this one off. Let's plug it in here. You'd have -1 times 1 minus 1. Well, that gives us -1 minus 1, which is -2. Still not equal to 0. Cross that off. Okay, -1 times 1 plus y value of 1. That gives me -1 plus 1, which is 0. Okay, so this is looking good so far. Let's make sure we can eliminate the other answer choices. So again, -1 times 1 would give us -1 plus the x value. The x value is -1. That gives me -2. So I can cross off D. Here, if I plug in -1 for x, -1 plus 1 cubed is 0 cubed, which equals 0. Okay, so this one looks okay too. So now we've narrowed it down to two choices, either C or E. That means that we're going to have to choose another point to plug in and test. Let's have someone choose a point for us. Anyone want to type in a point that we could test? Okay, what about, let's see. If I plug in -1 for x, so if I chose another -1 and then a different y value, this one wouldn't change. Let's take a look at this. Let's choose -2, -1 and see what happens. So -2, -1 should be right here. So we're going to see what we get. So if I plug in -2 for x, -1 for y, plus -1, which is the y value, I get 2 minus 1, which equals 1. That looks like it could have a slope of 1, so that looks okay. Let's try down here for E. If I plug in -2 plus 1 cubed, I get a slope of -1 cubed, which is -1. Well, the slope here is definitely not -1, so we can eliminate E, and the answer is C. So we had to plug in some points here to find the solution. Questions on how I did that? It's tedious. These problems can be tedious if there isn't an easy pattern to recognize. Okay, let's take a look at the free response question. Part A asks you to sketch a slope field. So you should have chosen some points to plug in. You didn't have to do the exact same ones as me, but what I did was I first thought about when is the dy dx going to be 0, when is the slope 0? Well, the slope's 0 when x is 0. So I chose x values of 0 and then y values of different numbers, but not a y value of 0. If you had 0 over 0, that would be undefined. So then I went to all the places where the x value is 0, and I drew a slope of 0, except at the origin, because 0 over 0 is undefined. Then I thought about, when is the slope going to be undefined? Well, anytime y is 0. So if it's undefined, that means we shouldn't be drawing in anything. So whenever y is 0, there should be no slope. So you can see I just left it blank. Then I thought about, when is my slope 1? 1 comma 1, 2 comma 2, negative 2, negative 2. Those things were there identical, and I drew that slope in. So 1, 1, I drew it in purple here. So 1, 1, 2, 2, negative 1, negative 1, negative 2, negative 2. And that was on this line here, except at the origin because you can't divide by 0. And then I thought, when is it negative 1? Well, when these are the same number except one is positive and one is negative. So that gave me these slopes of negative 1. And then I didn't write it down, but I thought about some of the other points on the graph. So here at 2, 1, your x is 2, your y is 1, so you should have a slope of 2. Here your slope should be negative 2. Here your slope is 2, negative 2. And these green ones represent a slope of 1/2, negative 1/2, 1/2, negative 1/2. So that's A, sketching in the slope field. Questions there? Okay, B says sketch a solution curve that passes through 0, negative 1 on your slope field. So I'm going to go to 0, negative 1. That's right here. And then to sketch a solution, I need to draw something that follows the curves here, that runs parallel to them. So looking to my left, these are negative slopes. So I'm going to run parallel, try to run parallel to those. This is going to look something like this, because they're getting somewhat steeper, and then running parallel again and getting somewhat steeper. Okay, so that is B. We just sketched a solution curve. C, find the particular solution to the differential equation with the initial condition. So for C, they're asking us to actually do algebra. So we have dy dx equals x over y. We can solve this by separating our variables. So like we've practiced before, I'm going to multiply y to both sides. I'm going to multiply dx to both sides. So my y's cancel, my dx's cancel. I get y times dy equals x dx. And then I can integrate. So the integral of y is 1/2 y squared equals x squared over 2, or 1/2 x squared, let's keep it consistent, plus c. Okay, now I can multiply both sides by 2. If I do that, I get y squared equals x squared plus c1, right? It's 2 times this constant, so this is a new constant. And then I could think about solving for my c value here. So we have this condition of 0, negative 1. If I plug in negative 1 and 0 for x, I get 1 equals c1. So that was us using the initial condition to solve for c. So I get y squared equals x squared plus 1. That means I can now solve for y. I can square root both sides. I get y equals the square root of x squared plus 1. And that could either be positive or negative. Let's think about which one makes sense. If I have, I'm going to do the positive version and plug in our given point, and the negative version and plug in our point. So if I plug in negative 1 for y and 0 for x, I get negative 1 equals the square root of 1, which is 1. Well, those aren't equal, so that can't be it. If I plug in negative 1 here and 0 for x, I get negative 1 equals the square root, negative times the square root of 1, which gives me -1 equals -1. So that works. So my particular solution here is y equals negative square root of x squared plus 1. Okay, questions there? This kind of puts everything together that we were learning about slope fields, sketching a solution curve, and then the rest of Unit 7, which was learning how to find the solution to a differential equation, and then using a condition to find the particular solution. Oops, sorry. Okay, if there aren't any questions, we'll sign off. There will be 2 Khan Academy exercises for you to work on. And then what I'm hoping to do, either for Wednesday or Friday, is create some sort of quiz or summative so we can see how we're doing overall on this. But I'll post about that either tomorrow or Wednesday, after I figured out how to try to make a quiz work for our class online. All right, as always, feel free to reach out with questions. If you're getting problems wrong, feel free to send me your work and I can give you feedback. And have a great rest of the day. Bye, guys.